Hi, this is Dr. Joby. Welcome to Topic 8, Physiology and Psychophysics. Up until this point, we've been looking at a broad history of psychology, and what we have found is that the big questions of psychology, why are we here, who am I, how should I act as I'm here, what is reality? What is this thing we call reality? These are all questions that have existed since the beginning of intellectual thinking. And we saw that the history has shifted from mythos, from the mythology, from the grand narratives of religion, which still continued to this day to answer the questions. And we found that in the ancient world, in the East and the West, a certain diversion started to happen that we call philosophy. And in both the East and the West, certain religious traditions branched into philosophical traditions. We most notably said that Thales was one of the first Western philosophers who looked for answers through thinking and through the natural world rather than through mythological or supernatural explanations, grand narrative explanations. We also found that in the East, certain diversions from the Vedic cultures and into Buddhism, we see a split happening where certain Eastern philosophies separate themselves from theology. What we call psychology today was not always referred to as psychology. We've found this to be the case through history, but the questions are pretty much the same, and the methods for exploring those questions are unique to that particular culture, that particular time period, the zeitgeist of that particular time period. Well, what we also call psychology today, as we have found, is a very broad term. Some psychologists are firmly rooted in understanding psychology as a natural science. This might be what has been called biological psychology, today maybe neuroscience or neuropsychology, anything that is looking at the physiological processes of the human being, that is the central and peripheral nervous system, the endocrine systems, as the interface between the individual's personal perception and the external physical world, would be taking a very natural science approach. And natural science is typically built, as we found, on cause and effect relationships. It's the idea that there is an objective world and a subjective world. Subjective meaning it's the point of view of the individual perceiver. Subjective and objective is the thing as it exists in itself out there in the world. There are other areas of psychology. I'm thinking mostly of psychodynamics, psychodynamic theories, humanism, even cognitive psychology does not necessarily hold into some aspects of cognitive psychology, does not necessarily identify itself with the natural sciences. Instead, they identify themselves with what could be called the mind science, the human sciences, or humanities-based psychology. So things like humanism and psychodynamic theory, these all come from a branch of philosophy, a post-Kantian philosophy called continental philosophy. And we see figures such as some of the romantic figures that we just studied, Kierkegaard, Rousseau, Nietzsche, Schopenhauer, and through the 20th century, figures like Martin Heidegger and Jean-Paul Sartre, people we're going to be studying next, looked at psychology not through the physiological, not through the psychophysics lens, but through a more maybe spiritual lens, maybe more in line with what we see in theology and philosophy, some philosophies. But right now what we're going to look at is this period in history, which is the the very late 18th century into the 19th century, and the quest of physiologists. Physiologists were individuals who studied how the sense and nerve systems worked, how the sensory organs worked as an interface with the external objective world. So this is really rooted. These are individuals who are looking at anatomy and physiology and exploring the link between the perceiver, the sense organ, and the objective world. These are, of course, the assumptions of the natural scientist, that there is some sort of a separate external reality that's separate from the viewer. This is a controversial debate whether or not there is an objective world, or if the objective world is always dependent upon a perceiver, an individual. For example, if you have a rainbow, there are really three things necessary to experience a rainbow. You need the water droplets, you need the sun, and you need someone to see, someone to perceive. If there's no perceiver, there's no rainbow. And this is one of the main criticisms of the natural science view, or the physiological view of psychology. Well, this story we can really begin in the 18th century with an individual experience. It turns out that in the mid-1790s, 1795, there was a royal astronomer named Neville Maskelyne, and Maskelyne had an assistant named David Kinnebrook, and they were using what's called brass lab technology. They were using these devices to measure how the celestial patterns were taking place, the movement, as it is, of stars across the sky. And Maskelyne found that there was a consistent error between his and his assistant's readings, and he fired his assistant. He reprimanded him and fired him for sloppy work. Well, it wasn't until 25 years later that a researcher named Friedrich Bessel was looking into the matter and found that there was a consistent difference between the readings of Kinnebrook and his boss, Neville Maskelyne. And instead of seeing this as sloppy work on the part of the assistant, he came to the conclusion that this was an individual difference, that there were different reaction times between different individuals. He referred to this as the personal equation. And this personal equation really becomes the birth of what we today call experimental psychology, lab psychology. The kind of stuff that dominates the academic natural science world of psychology, looking at this personal equation, this difference that we all come into the world with different sensory apparatus, with different abilities in eyesight, in tactile sense, in olfactory sense, gustatory sense, auditory sense, and examining how those sense organs work before perception, how those sense organs work to come in contact with the objective world. So what we're seeing here is something that's very much rooted in this natural science idea of a cause and effect relationship and an objective and a subjective world. And keep in mind, this is not the case for all of psychology, especially humanism finds a lot of problems with this approach. Well, we find here a discrepancy between an individual's experience and what the natural scientists refer to as reality. So what we're going to look at in this lecture is some of the major figures and their ideas of this thing called psychophysics. And this is of the 18th and 19th century. So in other words, the late 1700s into the 1800s, and then how one of the figures who, Helmholtz, who was the research advisor of another figure, Wilhelm Wundt, how this transition took place from the idea of psychophysics, in other words, physiological anatomy and physiology of the sensory organs, how psychophysics became psychology, And I don't mean therapeutic psychology at this point. I don't mean humanities-based psychology. What I mean is an academic discipline, a laboratory psychology that modeled itself on the natural sciences, which ultimately enabled it to become an independent department of its own, field of study of its own in a university system as part of this natural science model. So when you think of the thing that really spurred the birth of what you would today consider physiological experimental lab psychology, psychophysics is it. To give ourselves a little perspective of where things stood in the 19th century, there were really two main views of how the sensory nerves worked. One was still being used, a holdover from René Descartes, and he had a view that the nerve systems were fibers that connected the sense organs to the brain, and there was some sort of animal spirits, some sort of energy that flowed through these tubes from the sense organs to the brain. That was one view that was dominant up until through the 19th century, until the 19th century. And the second was by David Hartley, and his view that the nerves were these fibers that had certain vibrations, and these vibrations were conducted from the sense receptors, and these vibrations traveled from the sense receptors to the brain, and from the brain to the muscles. So these were the two. They're very similar kind of ideas. One involving some sort of animal spirit, some sort of energy, the other involving vibrations. A major step in the development in the 19th century to looking at this discrepancy between an individual's experience and the objective natural world outside of them came from a British physiologist named Charles Bell. And Bell was doing some investigation, what we today call experiments, on rabbits. And he laid down what today we would understand as nerve specificity. In other words, that there are specific brain and nervous networks or sensory organs that are specific to certain stimuli. So in other words, if you put a flashlight to your ear, you cannot hear light. The light waves are particular to the sensory organs of the sensory receptors of the eye. The sound waves and are specific to the sensory system of the ear, etc. So this is called the nerve specificity. So this is one of the first physiological approaches to understanding our connection with the assumed external world, and the pre-perceptive experience of that world in an individual. So just looking at the sensory organs. This led to what historians have come to call the Bell-Magendie law, and that in physiology, this law that there are two types of nerves, sensory nerves and motor nerves. And you understand this from studying in the Introduction to Psychology courses. It's interesting to point out that most of the research that's presented in an introductory psychology textbook on biological psychology is research that was done in the 1800s, the 19th century. We often see it accompanied by modern technology and neuroimaging, but most of the concepts were laid down at this period in history. Things such as nerve specificity, this Bell-Magendie law, in other words, afferent and efferent nerves, motor and sensory nerves, in other words, and even things like the speed of a neural impulse. This is all 19th century physiology. So building on the Bell-Magendie nerve findings of afferent and efferent nerves, or motor and sensory nerves, we have a German professor of psychophysics, or physiology at the time, Johannes Müller at the University of Bonn, who really lays down the doctrine of specific energies. He shows experimentally that there are that each nerve system, each sensory system has a specific stimulus that is associated with it. So the work was laid down by Bell, and it was really established by Mueller, the idea of hearing sound waves, of seeing light waves, of touch receptors in pressure and temperature, the sensation of heat and coldness in the skin, etc. This is really the work of Mueller. Mueller based his ideas of psychophysiology on Kant's idea of a priori knowledge, whereas Kant proposed that the mind organized the information, the sensory information. Mueller felt that he had found that it was the sensory organs were this bridge between reality and perception, but still it was the sensory organs themselves that fit into the Kantian mode of a priori knowledge. So in other words, the sensory organs themselves were a certain type of built-in knowledge that it was served as the interface with the objective world. Now, despite this commitment to experimental, empirical investigation of the interface of the sensory organs between the physical world and the psychological world, Mueller was a vitalist, and a vitalist was someone who felt that you could explore the processes of psychophysics, the interface of sensory organs with the physical world, but that the physical processes in themselves did not explain the entire phenomenon of perception, of experience. And that's the core of the vitalist. Opposing this is someone named probably the most famous physiologist, Hermann von Helmholtz. And Helmholtz was very much a materialist. So Helmholtz came from the physiological position that the sensory organs, the physiological processes are responsible, or can explain our perceptual experience of the objective world, the physical world. Helmholtz and his followers were so committed to this idea of reductionism, materialistic reductionism. In other words, experience comes back to, ultimately is caused by a physiological explanation, that they signed an oath. That oath goes something like this: no other forces than the common physical chemical ones are active within the organism. In those cases which cannot at the time be explained by these forces, one has either to find the specific way or form of their action by means of the physical mathematical method, or to assume new forces equal in dignity to the physical chemical forces inherent in matter, reducible to the force of attraction and repulsion. So what we find here is this oath that he and his students, his research assistants, signed, really claiming a reductionistic, mechanistic, and materialistic view of psychophysics, of the physiological world. And so when you think of maybe even positivism that we've discussed in the past, when you think of a very natural science approach to psychology, so I'm thinking neuroscience and biological psychology, any school of thought that rests upon materialism, mechanism, and reductionism. Those are three terms that if you've forgotten, you should go back and read in chapter 1 of your text. These are principles that are firmly established by Helmholtz. Helmholtz is probably the single most prolific contributor to psychophysics. And remember, he was the research advisor of Wilhelm Wundt, whom we're going to be studying in a future lecture. So Wundt was very much influenced by Helmholtz. Let me give you an idea of some of the principal ideas that Helmholtz contributed. Here's a list of these, and I'll explain them. Principle of the conservation of energy, the speed of nerve conduction, so in other words, how fast neural impulses travel. He talked about, of course, the interface of sensation and perception. He had a theory of color, the young Helmholtz theory of color. Looked at auditory perception. So we are seeing so in other words, the resonance place theory and auditory perception. These are all things you study in Introduction to Psychology class in the biology and the sensation and perception chapter. Also in a course that would focus on physiological sensation and perception. This is all Helmholtz laying down the foundation, and much of what he laid down continues to be what is taught today. So Helmholtz's idea of the principle of the conservation of energy, following physics of the time, Helmholtz proposed that the energy that's within a sensory system is neither created or destroyed. It's a constant energy within the sensory system. He also calculated the rate of nerve transduction. So in other words, how fast neural impulses travel. It turns out it's slow. It's about 90 feet per second. And he discovered this through a series of experiments with frogs and muscle impulse with electricity, thinking that electricity at this point is becoming a major interest for physiologists. Electricity and magnetism. Many experiments are being conducted with electricity and the nervous system. Helmholtz, he proposed his theory color, in which it's called the young Helmholtz theory color, the trichromatic theory, in which he said that there were three separate unique receptor cells for three basic colors, and that these were in the eye, in the retina, and that these receptor cells were the literal bridge between physical external color and our sensation of color. Of course, this is not the only color theory, but this is the trichromatic that's still taught today, the Helmholtzian view of how color is sensed. And finally, Helmholtz did a great deal of research on auditory, on hearing, the sense of hearing, and he developed the resonance place theory of auditory perception. This is the idea that inside the cochlea, the little areas of the cochlea, of this spiral-shaped inner ear organ, that different areas are stimulated by different wave frequencies that sense what we come to call pitch, frequency, etc. So these are all the ideas that are still used today in the 21st century, and what are taught in both Introduction to Psychology courses and Physiological Psychology courses, all completely developed and promoted in the 1800s. Our next topic of interest in psychophysics, so this is 19th century physiology, is the figure of the German-French physiognomist Franz Joseph Gall. Now, Gall is remembered as being the pioneer of what's called phrenology, although he didn't use the term phrenology. And he didn't popularize phrenology. That was done by one of his students, Johann Caspar Spurzheim. And Spurzheim really promoted phrenology as a way to understand intelligence of individuals, the differences in personality. Phrenology comes down to the very basic idea that there are specific physiological structures, in other words, bumps on the skull, that were made from different protrusions of an exercised brain, that one could predict and identify personality characteristics, intelligence, political leaning, sense of humor, all sorts of characteristics from feeling the bumps on the head. Now, this is really a tradition in the 19th century called physiognomy, in which body structure, body types, facial expressions as well as facial structure, were used as correlates to predict personality and character. So Gall established his research. He did some interesting studies where he predicted the personality of people such as Napoleon Bonaparte based on a cast of Bonaparte's head, René Descartes, etc. But it wasn't until Spurzheim, who was really a promoter. Johann Spurzheim was clearly a capitalist a marketer for the idea of phrenology, called it phrenology, and marketed it in the United States and in the most English-speaking world, so in the UK as well. And little storefronts popped up all over the place for predicting one's personality through phrenology. Now, of course, this was eventually discarded. I guess you could use the term debunked. But there were some basic principles that really were important and central to the history of experimental lab psychology and psychophysics and physiology, and that is the idea that there are mental faculties that exist, but they are different in each individual, so individual differences was stressed in phrenology. There are specific areas of the brain for specific faculties. This has been a popular idea through the 20th century. And also that if there was a certain exercise of a certain characteristic, that would become reflected in the brain structure. In phrenology's case, this is through a bump on the skull. In 20th century neuroscience and 21st century would see this as a correlation of neural bundling in the skull, but this in the brain rather. But this is really the foundation of this attitude of specificity, brain specificity with the sensory perceptual system, and so this is how phrenology enters into the history of psychology. Another figure, Pierre Flourens, was one of the first to compare human brains with other animal brains, such as dogs and cats. And Flourens used a method called extirpation. And extirpation is the actual destroying of areas of the brain in order to see what correlates are happening physiologically. So Flourens was challenged much of what Gall had to say and about phrenology, but he also laid down the foundations of using the extirpation method for understanding the relationship between brain structures and behavior, emotional experience, physiological movement, and sensory experience. Also coming from this 19th century physiology approach is Paul Broca. Now, Broca is known mostly for Broca's area. This is the area of the left hemisphere of the brain, most typically in the left hemisphere, not always, having to do with speech production. And Broca is really remembered for entering into physiological and psychophysics research, the method of the clinical method. That is looking at individuals such as Phineas Gage, the famous Phineas Gage case, individuals who had brain damage or had some sort of an accident, and then studying those individuals. Today we still use this method in physiological psychology and neuroscience, the clinical method. And Paul Broca introduced this method in the 19th century. Also hailing from this period in the 19th century is Carl Wernicke. You know Wernicke's area on the left temporal lobe, having to do with speech comprehension, with the comprehension. And again, this is in the mid-19th century, the 1800s, where Wernicke's area is described. Another 19th century figure who appears in psychology textbooks, physiologist Ernst Weber, known mostly for what we call as Weber's law. I like to say that this is probably the only law that's ever discussed in psychology, and it's really arguably not psychology, it's physiology or physiological psychology. So this is the law of how the muscles perceive weight changes. And this is known as kinesthesis. And kinesthesis is the sense of the muscle organs, knowing proprioception, knowing where the arms and body are positioned without looking at them while the eyes are closed, etc., and the differences in weight. So Weber did research on kinesthesis as well as on the tactile sense, skin. And some of the major things that he proposed was the 2-point threshold, the idea that there is a maximum or minimum space at which 2 points could be felt on the skin as 2 separate points and not one single point of pins pricking the skin. He also discussed at length that the tactile sense is a collection of many different sensory experiences, such as temperature and pressure. And he was also a pioneer with the JND, the just notifiable difference. In other words, how much of a certain stimulus must be added or subtracted to an already existing stimulus to enable the sensation of a change. So in kind of contemporary terms, if you've ever played with the stereo and turned a dial on the stereo volume up to when you could hear the change happen, that would be a just noticeable difference, JND. So this all goes back to 19th century physiological research, pre-psychology. One of the most colorful figures of the 19th century is Gustav Factor. Now, Fechner was a close friend of Wilhelm Wundt's, and in fact, most of the laboratory researchers will find that Wundt conducted were replications of Fechner's work in physiology and psychophysics. I think we can really call Fechner a psychophysicist. He had a very wide breadth of understanding of the human condition. And this will give me one example of this. We often see in introduction to psychology textbooks and theories of personality textbooks what's called Freud's iceberg. It turns out that Freud never discussed the iceberg, never wrote about an iceberg topology of the mind. Instead, it was Fechner who proposed this model. Freud's biographer, Ernst Jones, quoted Freud as saying that he believed that Fechner's iceberg model was the best way to think of the topology of the mind, but Freud himself did not propose this iceberg model, although it's often misunderstood and misrepresented as Freud's iceberg model. It's really Fechner's iceberg model. So this is an important thing to remember. Fechner had what he called the night view and the day view. He was very conflicted. His night view was one of a physiologist, that experience, perception, sensation, the human experience could be reduced down to materialistic, physiological, objective, laboratory science sort of physiology. But he was conflicted because he didn't think this was the whole story. He took also what he called the day view or the light view, and that was one that focused more on spirituality and consciousness and the phenomenon of existence of the mind. So we have a complex figure here, and his day view and his night view, he expressed both aspects of this. So some of his research is very fascinating on color perception, on light perception, on all sorts of interface between the perceived existing world and this physiological world. And he was a Spinozian. He followed Spinoza's idea that consciousness was something that existed in the world in all objects, some level of consciousness. So this is called panpsychism. All things have some sort of physical consciousness, some sort of awareness, which might seem maybe bizarre to contemporary physiological biological, natural science psychologist, but if you really study this idea of some sort of level of consciousness, and if you remember back from the Spinozian view, it's really something that continues to knock on the door of psychology. So when Fechner became critical of the night view, physiological reductionism, he would write essays. He wrote essays criticizing physiology. Even though he did physiological research, he was critical of it. And when he wrote these essays, he used a pseudonym, Dr. Mises. And in Dr. Mises was this aspect of himself where he actually criticized his own work as a physiologist. So he was always navigating between what he called the night view and the day view. And he wrote a number of books and articles. I'll give you some of the titles to give you a sense of how he's writing and what he's writing about. One is called The Little Book of Life After Death, Nana, or Concerning the Mental Life of Plants, and Zenda Avesta, or Concerning the Materials of Heaven and the Hereafter. So he was looking into non-physical or metaphysical aspects of the human condition as well as physical. So this is really a great model of what we might today call an interdisciplinary study. He is also the pioneer of the absolute threshold, not just the just noticeable difference of perception, but how much of a stimulus must be present before it is sensible, before it can be sensed, and that's called the absolute threshold. He did further work into the differential threshold that was laid down by Weber previously, and ultimately became a major influence, of course, on Freud, as well as we'll see, Wilhelm Wundt, who inherited and was entrusted with Fechner's papers when Fechner passed. It's interesting to note that many historians consider Fechner to be the true originator of psychology. If we make a distinction between originator and founder, Fechner would certainly be an originator of psychology. Wundt, as we were about to see, would be considered a founder. Wundt didn't, much like Freud, took much of what was already existing in physiology, replicated, rebranded it as laboratory psychology to have it enter into the academic discipline as an academic psychology program in a university. And so it's important to remember that these were the teachers and friends of Wilhelm Wundt. Wundt as an analytical philosopher. In other words, his influences are greatly in psychophysics and physiology, and how he then takes psychophysics and physiology and develops it into what we come to know as academic psychology, which is different than psychology that was being done at the same time in psychodynamic circles such as Sigmund Freud, etc., which was outside of the university system as psychotherapy, as a therapeutic process. Really two different histories here. So we're going to next turn to Wilhelm Wundt and some of the earlier pioneers of the founding of the academic discipline of experimental psychology.